Let's take a moment to explore where to find things in Array 4.3, a little bit about navigation and where the code will be lying that you might be interested in looking at. Referring to DB013, the Array 4.3 User's Manual, and skipping ahead in it to Section 2, this table indicates which features exist in each of the two environments, SaneForth on the x86 and Polyforth on the 144. Not everything is planned on the 144, and some of the things that are planned aren't done yet. The things that are marked TBD have yet to be implemented, but will be eventually. This section talks about the environments in the two systems, and they differ a little bit, but we've made them similar enough that you shouldn't have too much difficulty navigating between them. For example, wherever there's an 18-bit number required in either the IDE or in the compiler, you will need to express that as a double precision number using a decimal point or a comma, any of the Polyforth characters for denoting a double precision number. And the reason, even though 18 bits does not require double precision in the case of the x86 with a 32-bit cell size, we don't want you to, well, we didn't want ourselves to be confused about which system we were on and having to worry about that very much. So here is the layout of mass storage, the layout of the main 4800 block area, which is 2400 blocks of source, 2400 blocks of shadows. The left-hand column here indicates what's in the x86 version, and the right-hand column indicates what's on the Polyforth system. The light green shaded index pages, and each one of these is a 60-block index page, are those which are excluded for proprietary reasons. At any rate, you will see some differences, and this is your gross reference on where to find stuff on the two systems. Anything that's on both of them is in the same place, of course. This is a larger scale disk layout depiction on each of the two environments. And from that on, we talk about utilities. So let's move on to some examples of actually finding our way around. Here we are talking to ArrayForth on the x86 right after we've started the program. And if you're ever doubting who you're talking to, just say who. When either of these systems is up and fully loaded, it will tell you who it is. That might save you some consternation later. The easiest way to look at the source code on a standard Forth system is to say QX to show you a quick index. Shows you an index page, 60 blocks on a mod 60 boundary. Like 0 space QX will show you 60 blocks starting at block 0. Each block is denoted by the topmost line, which generally we put a comment in saying what it is. This is all code loaded in the 9 load, if you will. It's additional to what's in the nucleus. NX will show you the next index page. BX will show you the preceding index page. SX will show you the shadows for this index page. SX will take you back to the source. So looking around, the bottom part of the system, as you notice from the disk layout page or a table in the manual, is mostly concerned with the operation of the x86 system and with proprietary stuff like our CAD tool for the chip. But aF3 is the name of the starting block of the ArrayForth system. And if you say aF-3 space list, that's the load block for the Array4.3 environment. On the x86, this is a capsule, which means that you can get back to it at any time by simply saying aForth, as is displayed on line 1, aForth. aForth will get you back to this just as though you had just loaded it, which it's already been loaded. On the chip, we actually load it, and it can be forgotten because we have not so much memory to work with. If you want to see the index page surrounding any block that you're looking at, simply say AX. And there we are looking at the index page at the beginning of ArrayForth. The left-hand column here is mostly blocks that are concerned with the structure of a bin, which we'll discuss later, and with the assembler, which could be called a compiler. It compiles something that sort of looks like high-level forth, but it really generates directly machine code for the chip, so we call it assembling. Assembling, which looks like colon definitions. So this code in here is all concerned with generating direct code for a node. These blocks here are examples that we'll get to shortly that do something to prove that you've got the chip under control. This code here in the middle, starting at 1590, is known by the block examine. See, we're looking at 1590 now. And if we loaded it, we'd say examine load. This code here is all concerned with examining and looking at and dumping and comparing the contents of bins, which is the object code that we compile or assemble source code into. On the right-hand side, this is all concerned with generating boot streams. Boot streams that can be injected through a boot node or boot streams that can be injected through node 705 from a SPI flash. The next one, NX, consists of the IDE, the external IDE, right here. All of this code is for running the external IDE. The code in this column is concerned with generating boot streams of various sorts. These two boot streams are for serial booting through node 708, and these two boot streams here are for using the SPI flash as the boot source. This is SoftSim. SoftSim is basically the software simulator at the instruction set level of up to 2 chips worth of nodes, all running code. And we will get into that in a later video. But for right now, that's where it is. And so next index page is other stuff, which is not really germane here. The next place where things get interesting is 1860 space QX. This is the mechanism for testing the chip. And all of this business here on the left side is the mechanism for making the tests. Self-test and auto-test, which you've probably encountered before, are here. This is an SRAM interface tester, mainly to make sure that all of the address and data lines are intact. The next index page, NX, is in fact all of the test code, the code for the specific processor and data bus and memory, etc. tests. All of these tests, most all of these tests are run for each node in the chip, except for the ones that are just here. These all are additional tests which are run internal to every node on the chip during a self-test, for example, and certainly are what we do when we're testing the chips ourselves. And finally, 2220 is an interesting place. This is where all of the ROM code is assembled. The next index page, which we get to by saying NX as usual, is library code, if you will. These are object modules that were thrown around for various purposes, such as, for example, accessing SRAM, or for the snorkel and ganglia. And finally, 1980 is the polyfourth virtual machine in the left-hand column, and the 10BASE-T Ethernet NIC in the first 31 blocks, 31 blocks of the rest of the index page. That will all be interesting reading for you. But sure enough, if you look at block 1984, you'll see here that these are in fact, entry points into a node, the stack node, for fourth primitives, such as negate, better yet, XOR, which is XOR and then pop. Negate is 1 minus invert, which is the same as invert 1 plus. And likewise, negate is used down here in subtraction, negate plus. This is all very compact, but at least you'll find this interesting reading, I'm sure. So that's how to find your way around in the code.